Hello, nice to see you again. I'm Chris. In this video, it may be a little bit long, but in this video I'll show you how to use OMRON.Let CPU and SL5700 configure EtherCAT network and FSoE network. I hope you like this video, and let's start. Before we start the video, then let me introduce myself again. I'm Chris. I'm come from Hong Kong. Now I'm working on some factory automation stuff. If you like me, if you want to follow me, that here is you can see my blog, my YouTube channel, and my Twitter account. Okay, so let us to introduce this hardware first. This one is SL5700. It is safety controller that you can install next to the NX CPU. It is safety controller. You can use this controller. It is chip safety and EtherCAT and FSoE. The maximum is 254 safety master connections and up to 2032 safety I/O. And for this module, they have 4 megabytes of memory capacity. Then you can back up and restore the data with the SD card. So here is the other main characters we will use in this tutorial. It is a EtherCAT couplers. It's come from OMRON. The model number is NX ECC203. It is an NX series EtherCAT coupler with 2 ports in here. Then for cycle time is minimum to the 125 milliseconds. And for the maximum IOs, you can use 63 IOs unit and 10 ampere of currents. And this screw put in type for you is very easy to install to do the wiring job. So here is the configurations. Our configurations are using here, and here's the wiring. I know that it may be not easy to see, and I give you a full explain to what actually I'm wiring for. Okay, so here is a coupler and the PF0630. It is the external power supply. So I will just put the 24 volt on the A, and then to pass the electrical supply to the PF0630. And for the ID4442 and OD4256, I'll connect to 3 bottoms and 1 lamp. And this is the IO-Link module. This ILM400. For this one, here I have a screenshot. It is from reference from the OMRON menu. So you can just reference the color. The IO-Link sensor, they have a standardized color marking. So you can just follow the black is connecting the first terminal, and white is on the second terminal, and the ground blue, etc. So for this safety I/O, the safety input that I'm using in this time is SID800, and for safety output I'm using SOD400. For SID400 in here, as you see the screenshot, I'm using the emergency stop to connect to SI00 and SI01 with a testing input. For here, I'll just use a single channel with the test pulse. I'll connect it as a lamp. Okay, for my explanation is enough. I will shift to the camera and let me to explain a bit more about what kind of hardware that I'm using this time. Okay, let's go to the camera side. Okay, now I turn the camera and you can see the real hardware in my tutorial. As see, this one is the NX CPU, and I installed the SL5700 in here, and here is the EtherCAT coupler. For this port, this is the EtherCAT port. The EtherCAT port is connecting to the input port of the OMRON EtherCAT coupler. And here you find the slide I/O. And for example, this one is the external power supply, and here's input, output, I/O link, and safety input, safety output. And now it's in the normal conditions, so you see there's no error in the EtherCAT port and no error in the EtherCAT coupler. And the safety input and output and all to slide in the normal condition. And okay, let's see here. You'll see this one is the OMRON IO-Link sensor. It's connecting the LM400, and here is emergency stop. It's connecting the safety input and this is the LAM output is connecting to the safety output. Okay, I think my explanation here is enough. Now we can start to make the configurations and make some simple program. Let's go. Hey guys, now we start the Smart Studio. This is a engineer tubes from OMRON. That is, we used it to configure our NX CPU project. So let's start. And first one, now before we create the project, we need to select the CPU, and in this case we are using NX102 and 1220, and you also need to match the version that you're using here. In my case, I'm using 1.48. Then we can create our project name. In this case, I will call it FSoE, YouTube, YOUBE, okay, and English, and create. Great. Then our new project is created, and now we can start to make our hardware configurations. The first of all, we will insert our safety CPU. So in this case, you go to configurations and setup, and open CPU extension racks and go to CPU rack. In default, you only have the NX CPU in here, but need to add our safety CPU in here also. So in the right hand side, you will find two boxes. This very great function. You can filter what catalog of a module you would like to insert in your system. So go to safety CPU, and you see the module that we are using this time is NX SL5700. But my hardware is not very updated, so exactly that the CPU module, safety module that I'm using in my case is not 1.4, it's 1.3. So what we can do in here, we need to click the show all version button, and you will see all the version that of your hardware. In this case, as I mentioned before, we are using 1.3, right? So click on the NX 5700 1.3 and right click plus insert. Done. One step, then you insert your safety PLC into your system, and then we can go to then in the left hand side in the multiple explorer. Now you not just have your non PLC, you can also configure your safety PLC by click on this button, by click the drop down list. Okay, and here is our control in here. Then next one, we need to configure our EtherCAT network. So click on the EtherCAT options. Then in the normal, you only have your master. The first thing, you need to insert a coupler. So go to the terminal couplers, and you can find couple version here. And the coupler that we are using here is EtherCAT ECC203 with version 1.3. So you need to show all versions. Then you define EX, I think this one, right? EX33203, okay, and 1.3 at 1.3 version, this one, and right click insert. Okay, so now maybe sorry that the font is pretty small. That you can see NX ECC203 version 1.3 is inserted in your EtherCAT as your EtherCAT slave. Okay, now we need to configure the EtherLite terminal I/O that inside our EtherCAT slave, EtherCAT coupler. So just click. Okay, before we need to set up the load address. Actually, because on the EtherCAT coupler, there is a rotating switch to let you to set up the address of the EtherCAT slave. So in here, I set this 10. So I just put 10 here. Okay, and then we can go double click the EtherCAT coupler. Then in default, you only have your EtherCAT coupler and the end terminal. So now we need to add the terminal one by one. The first one, as I mentioned before, the first one I insert is PF0630. It is a power module. So go to I think system unit interface, a device. You will find a device called PF0630. Click on here and right click, insert. Okay, then just do it one by one. Then we have an input module called ID442. Go to digital input device and find out ID4442, right click, insert. Then same thing for output. In the output we are using OD4256. So where is OD4256? This one, right click, insert. Done. And we have a IO link terminal here. So go to IO link. We are using version 1.1. So right click, insert. Finally, we will have a safety input module and safety output module. Go to I think safety digital input device. Then you have the device we're using here is SID800 as version 1.0. Just click on the SID800. I think it's 800, right? Just a second. Yes, and then right click, insert. Great. And finally, you'll need to insert the output module also, safety, and SOD800, right click, insert. Great. Now you finish. Okay. Then we can configure our Ethernet IP port. I think here is controller and built-in Ethernet IP port setup, and go here, enter the IP, and here I use 1.v9. Okay, just close it, close it, close it, and close it. Maybe you can just use close over this, right? And before we go to the safety configurations, I would like to configure our IO link terminal. So click on the IO link terminal, and in here is the all parameter drop down list, and plus it, and configure port 2, because in port 2 we are connecting to an OMRON or IO link sensor. Here's the options called port 2 IO link device configurations, input data link, and output data link. So you need to reference that the IO link device that you are connecting to, because each IO link data will have different input data and output data. In this case, we will have 4 bytes input and 1 byte output. So the value that you change, then in Smart Start 0, they will show as a red color that will inform you that, hey, this value is not a default value. Okay, so, and then we can close it. We can open the EtherCAT network again, the terminal, sorry, and go to and click on the ILM400. It is the IO link terminal, and then plug the IO edit IO allocation setting. Then you can change the mapping. So by default, all is only have 2 bytes. So we go click on the input data set 2. It means the port 2. You can add our entry. Then here you need to find port 2 input data 2. They also have an array of 2 bytes. So then press OK. Now we have 4 byte data in here. Then press apply and OK. Done. And then go to IO mapping. I think it's our mapping. Then go to here and find out the ILM400 and go to port 2. I think they have data 1 and data 2. So you extend your data, the data that you want to get or you receive from the IO link. Okay, I think the hardware configurations in the long PS is okay. Now we can go to safety. So go to drop down list and select your safety CPU. So here you have a 2 menu. One is called communication setup, one is called programming. It means to do hardware configurations for example chip safety connections or communications or some exposure IOs. Okay, the first thing we need to set is we need to configure our safety input and outputs. So go to communications, safety IOs. Then you have this. Oops, sorry. Then you have a Unit 5 and Unit 6. These 2 modules is what we insert before in the EtherCAT coupler. So we can just drop on this. You have parameters. Click it. Then here's a very excellent screen here. Then you can directly see what kind of how to wire your cable, your device into the OMRON safety input terminal. So it is in this tutorial we'll use a emergency stop. So go to input device safety switch. There is a items called emergency stop switch for dual channel. Then you just select this item and drop to SI0, SI1. Then you will see that SI0 is connecting to the emergency stop, and then we've back to T0, the testing input 0, and it's testing input 1. Done. Then we can open again. Then we can configure the safety output also. So go to output device, generic device, and in this case we'll use single channel with test pulse. Just select this item, drop to here. Great, you finish. So the conversion is very easy. Now you finish the safety input or safety output, which kind of device you would like to connect in, then you know how to wiring. And then now the next steps, we need to set up some exposure IO. What is exposure IO? Exposure IO is that if you use a backup before that, you know that you need to map some input data or output data that is from safety program to normal program, or from normal program to safety program, and you cannot directly access these safety variables in the normal program, and also same field you cannot directly access the normal variables in the safety program. So you need to explore some IOs to make a share area, the network both of safety program and non-safety, safety CPU and non-safety CPU, to exchange the data. So here is what we've done here. You go to standards and slave IO, okay, and then go to exposure variables. And here is two options in here. This output and input. Output from safety CPU unit is the data output the same from the safety unit. So what we need to do in here, and just enter the device name, the variable name, data from safety 00. It should be boot type, any types. So just again, data from safety 01, and data from safety 02. And you can also use word in here, just a bool or byte. And in the other side is the input data. It means the data will be from normal program to safety program. So in this case, we will just data to safety 00, and then create again data to safety 01. Also boot types, no big deal, but we done it. And then we need to do the mapping. So how to do the mapping? You can just go to IO map, and here is some modules. For example, this one is for safety, and this one for Ethernet IP and for chip safety something. But in this tutorial for safety program, we only use just these two IOs. Just so we click for example, we click the input, safety input module, and right click and create device variables, and do the same time for the outputs. But you can choose select all and create times. But I'll just show you how to do this. And after that, you go to data and global variables. Great, all the data is created automatically. You no need to type it hand by hand. Okay, so now we can start to make some safety program. Just open the POIS program 0, and here is the safety program editor in Smart Studio. So we just define some variables one by one. For example, safety on, and I also have a called safety off. Okay, and then I would like to zoom it a little bit good, so I will go zoom to fit. I think not fit this one. Okay, this one's great. I think this one's great. Just a second. Okay, I would like to zoom to fit. Okay, come on. Okay, that's great. The first one, I would like to add a always off. Actually, you can use the insert value, but I would like to give a view value for them. Just right click, insert assessment, and here safety off is equal to safety off. And just add one more. Oops, not this one. One more line. I think. Okay, just do it again. One more line by using insert network below, and this time I would like to use a not function block functions. So go to pass and then not and search it. Okay, and for we insert a assessment like first, and then drop the not block in here, and copy say not if the safety off is not turning on, then we will turn on the safety on. It's not some difficult program, just easy program, right? And then I would like to have a reset signal that passing from the normal program. I would like to reset my safety safety input from the normal CPU. So I will add a variables here. I would like to use a bool, just put here. It should be reset. And right click here. I think here is better, right? Insert network below. Then right click, insert assessment, and then for here I say data to safety 00. Data to safety 00 is be reset. So this variable should be passing from the normal CPU. Great. Okay, now we can add another one network below. Okay, then we can close put my search in here. Then I would like to config. I would like to program my emergency stop functions, and actually you can build your own logic to control your emergency stop functionalities. But OMRON also provide the safety library for you. Go to safety function blocks, and here you will find a function block called FSF underscore emergency stop. It is the function block for ESOP, right? And then just drop in here. Then the instance will automatically create for you. Then you can just input the variables that you want to use in here. So for activate, I'm sure I need to activate this function block. So I safety on. And for the stop in is just input signal of your e-stop. So it'll be N6. N6 means it's the no number 6. Or yeah, no number 6. N6 underscore. Okay, sorry again. N6 underscore SI 00 logical value. I'll use this one. So when this one turn on, it means that emergency SI00 and SI01 both in on and without any error. Okay, and then for the S start reset, I'll use off. I don't need to use this functionalities. And for the auto start, also turn it off because I don't use it. And for the reset, just put reset. Okay, and then I would like to take these three flags back to my lone PLC. And so out here, I will create new variables for ready, and then create new variables for error. I create one more variables is work type for the dynamotic clock. Dynamotic clock is for this one. Okay, then we have to ready is equal to ready, error is equal to error, and dynacook is equal to dynacook. Great. And then I would like to pass this free signal back to our safety program, actually a non-safety program. I will insert below, and 1, 2, 3, and then insert assessment. The first one is, for example, ready is equal to data from safety 0, and then I will pass in the error also. So here insert assessment, error is equal to this one 0, 1. Okay, then I assessment again, dynamic code is equal to data to safety from safety 2. Great. And then finally, I would like to control my safety output. In this case, it's just a lump output, but I also like to control it. So first thing, I would like to add a OR output, OR block. So how to do this? I think you can go to bool operations. So there's OR block here, drop here, and then I would like to assign the output first. So select the output pin here, right click, insert assessment. It should be N, I think it's N7, yeah, log 7, SO00, and output value. Great. And don't worry, in red here, found you'll be not in red because now the safety program have safety logic have problem. So first one I would like to use is the safety function block signal. They offer emergency stop. I will use SF emergency stop 0 dot SE output. It means that if this one is turning on, it means that the safety the function block is activated, and the E stop signal is turning on, and it reset. So I will turn on my lamp, right? In this case, lamp is maybe some magneto or any coil that you want. Then I'll put N signal in here, and block in here, and block in here, right? So this I have the first conditions. So what is my next conditions? My next conditions should be if the module if the E stop is in ready mode, the function block is ready, but I put a not in here, and I put this a little bit more small. But what? But SF underscore let's copy here, okay? But it's turning on, not turning on. It means that maybe I didn't reset it, right? And I would like to add more input conditions. So what do? I drop it a bit more small here. I will right click and add input. Then I can add one more pin. Then data to safety 01. 01 or 00. So this also a device it come from my normal program. And then I'll add one more input. Then it should be N6SY SY00 logical value. Okay. So I now have a two signal to turn on my lamp. The first one, it is using the function block is OK conditions, and the other one is ready. The function is ready, but this is an output. But and also the E stop signal, the emergency stop signal is in true conditions. It means that maybe I didn't reset it. I will flash it in maybe 0.5 seconds something. Okay, great. My safety program is finished. So I go to controller, we can go to project, to build controller, to see is there any error in here. You can see here in output is no error, so it means that my safety project is without any problem. Okay, now we can start the normal program side. Go to the drop down list, and then to choose a normal program again. Great, so we'll close this one, and save it, and then go to normal program. And for first thing, I would like to create some data types. So go to what? Programming, data types. So the first one, I create some usual data types. It's very useful than different type of variables that you have same memory offset. So the first one I would like to create by2 boo. Okay, so and then create some member for them. The first one I do have by data, right? Sure, it should be by data. Then I have boo data. Oh, come on. This one, select here. Let's select here. Member. It should be boo data. So what's boo data in here is array 007 of boo. Just a second. Let me see what I say here. Oh, I think I put one more in here, right? Why? Okay, let's try again. This is boo, right? And here's 07. Oh, great. So in this case, this byte data variables and boo data variables, we have same memory offsets. So for example, it means if my byte data have a value called 01, then my boo data index 0 will be turned on. So this etc. For example, the value is 2, so the boo data index 1 will be turned on, just like that. And then we create one more data types, same theory, and create data types. So this one should be by2 work. Okay, then need to create some member for them. The first one is should be work data. Work data. Okay, then I create member again. So this one should be byte data, right? 2 bytes data. Okay, this here is 0.1. Okay, it should be byte data. I don't know why it's error here. Just a second. Okay. Okay, here it should work. Okay. Then I go to the structures. I would like to create data for our outlink sensor using this time. So the first one is DUT E3AS is HL500 MN, maybe process data ROCSS, and then byte 3. And I create some member for this boy. Here we have a control output 1, and then control output 2, and then I will have a alarm. It's called low intensity, SITY. Okay, I have one more is alarm for intensity, ISS in FISS. Just a second, it should be efficiency, FICINT, light intensity. Okay, great. And then I have one more member. It's called warning. One more member is called error. And then we can add one more data type. It should be this one. Okay, data. Then you get a member. The first one, it should be detection value, ECCTION. So for the detection value in here, I hope my spelling is not wrong. DECTION value. Okay. Then I have a lighting intensity, DNSITY. Then I have my status. So status should be this data type. Great. Okay. Function. The data type is finished. So now we can do the mapping. Save it. Open the for example, open the SL5700. Okay. CPU rack and sorry. Go to the IO mapping. And open the SL5700 and right click. Okay, so cannot do it this way. I think I can do it this way. Okay, click on the bus master, or even what you like. So you can just do like this also. This also work. And click the device variables. So all the device variables create automatically. It's just what we do, same thing on the safety program. And then do it for the coupler also. Right click. I think it's you can go to right click here, or you can right click in here. You can just write all the things. I think right click and create a variables. And then if you check on the data group variables, you can see all the data is defined automatically. You don't need to define one by one by yourself. Okay, and then now we can do the function block. So go to function blocks, right click, add st. I'll use st in here. And for the function block in here, I will give me name for FB EVAS actual file EAS EVAS actual 500. Okay, click it. Then we can define some in output. The first one I would like to define is IO data 1. Then one more is IO data 2. And then create one more is called IO EVAS. Then all this stuff is in out data. So, and then for the IO data 1 is the rate of byte. It should be 0 to 1. Let's copy it and paste it. And for the IO EVAS, it should be the data type. Okay, great. And then go to internal. You already define some internal labels here. First one is temp, and create new one. It should be U bytes to work. D. Okay, and then create one more is U byte to boot. And then here is byte to work, and here is byte to boot. Done. Okay, now we can start the programming. I just assume the our editor will be big. We will not do so many such stuff in here. So the first one is temp. Just temp is equal to 2. Okay, and then we will use our usual data type. U byte to work dot byte data 0 is equal to IO data 1 dot 1, and U byte to work dot byte data 1 is equal to IO data 1 0. I'll just make a swap for the byte orders. And then IO data EVAS dot detection value is equal to work 2 INT. So then we can pass U by to work dot work data. Okay, great. Then we can do the same things, and IOEVAS dot light intensity is equal to by to int. It should be directly use IO data to 0. Great, done. Okay, and then we can okay, it should be 1 not 0. It should be 1, yeah, 1. And then now we can use other one, U by to boot dot by data is equal to IO data to index 1. Then we can encode all the data with this usual data type. Dot status dot control 1 is equal to U by to boot dot boot data 0, right? And then do the same things. Status control 2 is equal to U by to boot data 1. IO E3AS dot status dot low intensity is equal to U by to boot dot boot data 2. And then IO E3AS dot, and this time we use status dot efficiency night intensity is equal to U by to boot data, I think it's 4. You need to reference the documentation of the outing sense that you are connecting in. IOEVAS dot status dot warning is equal to U by to boot, I think 6, yeah. And then we have IOEVAS dot status dot error is equal to U by to boot 7. Great. Then we can check the function block if any error or not. Yes, because what? Because yeah. For this one, it should be dot boot data. Dot boot data. Okay, it's my fault. Dot boot data. So after this one, I think still have 2 errors here. Let me check why we have error in here. Okay, so I think it's equal to work to U by to work dot work data. Okay, let me check why we have error in here. Let me check data type again first. I know here. INT, it should be INT. Okay, go to save it and then check again. Great, no error. Okay, so now we can program our main program. We build our function block, right? So by default, they using a ladder, and not ladder is good, but yeah, you know, I would like to use SC in here. Just right click program 0. It's program 0, right? I think section 0 is that. Just let me close it first. Close it, and then yeah, click here and go to program 0 and delete it. Okay, so then we can add a new program with ST. Then after that, we need to register this task. So go to task and plus bottom and kick our program 0. Great. Let's close it and then open our program. Great. Now here is our main program. The first one, I need to define some local, not this one, okay, delete it, some internal variables. First one is not ready. READY. Great. And then I would like to have 2 variables for B and O contact. Switch and O contact. Then I have one more. It's called NC contact. Then I would like to create 4 timers. So my timer 1, it should be T on. Then I just copy it, paste. Oops, and you can use array, but yeah, I just want to make anything simple. Don't use some advanced technical. So I think it's better for the beginner. Okay, 1 to 4. Then I would like to have a variables with usual data type is byte to bool. I used it so many times in here. It should be st by to bool. Okay. Then I will have a function block. So fb. Then this function block name just up to I use e3as1. Okay. Then I have a device for my outing data outing value, outing device. So device should be dut for process data. Okay, create one more. Then I will have a port ready for my outing port 2 ready. It's just a bool data type. Okay, save it and then submit. Great. Let me create some program here. First thing, I would like to create a 0.5 second on, 0.5 second off timer. On off timer. So my timer 3 is equal to, I'll call it, and now you can, okay, for the in it should be not, come on, not my timer, my timer, what, why, my timer 4.q, and I'll set it as 0.5 second. Great. And just copy it. Do the same for timer 4, but for timer 4 it should be the node and use my timer 3.q. And then I would like to pass this signal to my safety side. Data to safety. 01 is equal to my timer 3.q. Finish. And then now I would like to configure the input data. So I would like to check the log is ready or not. Log ready is equal to _ec underscore master error is equal to 0. It means there's no error in here, and not ec and com error table. Then you can choose which node you are looking for. I'm using node number 2, so it should be 2. Great. And then we'll check st byte to bool is equal to dot byte data is equal to 0. I'd like to insert the variables here first, and then we get st byte to bool dot byte data is equal to n3 input bit 8 bits. So actually you can use one data bit by bit, but OMRON also provide a byte data for you, a byte variables for you to access the whole channel in one time. And then B switch and no contact is equal to st byte to bool dot bool data 0. And the same thing, B switch and C contact is equal to st byte to bool and bool data 1. Great. We finish here. So and then we need to, I would like to also passing another safety signal back to safety side, long safety signal to back safety side. So it should be n1 data to safety 0 is equal to st byte dot bool value data, this number 2, because I have a input reset bottom is connecting to this module also, and what, and and one programming is no fault, and program is running, and not and run programming no fault, and no fault, sorry, and one programming no fault, and then n6 S100 logic will actually also directly access the input signal, or the status of the safety input directly here in the non-safety program also. Okay, so I done it. Then we can go to next step. So we can configure the output now. st to boo dot byte data is equal to 0. Okay, and then not ready is equal to, I think I would like to use the same one. Okay, so this time it will not be 2 but will be 3, and then I use my timer 1. I would like to call it for the in. It should be B switch for NO contact, and I'll give it 1 second, and not my timer to .q, and then I'll delete the parameters so don't want to use. Then my timer 2 and in is equal to my timer 1 .q, right? And for the time setting, I'll give you 1 second. Then that's delete what I don't need. Okay, great. And then we can st byte to boo dot boo data 1 is equal to B switch NC contact or my timer 1 dot q, and then finally we'll need to output data st byte data dot byte data. Great. Finally, for the outing, port 2 ready is equal to N5 port 2 in data enable, and N5 IO power turning on. And then we can do the node ready also. Node ready is equal to, so let's copy this one, direct to here, and then 0.4, and then we can call the function block. Okay, for the IO data 1 is equal to N5 port 2 data 1. Copy this to data 2, and then for the IOESA it should be device. Done. Okay, then we can try to build a project again. Make sure there's no error. Great. Okay, and then we need to, I think I configured the IP port, right? Just give me a second. Go to is it IP port? Yes, I figured. So then we can set the communications. Go to controller communication setup, and I'm using hub in here, just to these options, and then enter the CPU of your NX IP address of your NX CPU. In my case is 128.1.9, and then we'll test it. Just a second, this should be show that's okay. Great, and press OK, save it, and then go online. It should work, I hope. Yes. Okay, and then go to safety, Okay, then we need to stop our safety program. Okay, I think select this one. Why don't I select? Okay, just close it. Go to safety, and then we can stop my safety project, safety CPU first, and then go to debug mode. Yes. Okay. Yes. Okay. And then check our safety project. It need to take some time. Okay. Then we transfer the available comments now, and okay, and then press the pay button to run our safety CPU. It should work. Okay. And then we can I hope there's no error in here, and then we can go to our normal controller, and we can download our configuration here. Also need to take some time. Just yes. But it's not be complete. View again. Why? Okay, I think some errors happen here. Go to project. Check. Okay, no error here. So how about this one? Project view. It seems no error. Why is it not view? Okay, let's try again. Or maybe just a second. Maybe in go to project, we can rebuild our controller first. Okay, great, no error, right? Let's turn it on. Yes. Okay. And download the project again. Yes. Okay, you need some time, just wait a second. And okay, still maybe need 30 seconds something, but it should work. Now it's 80%. Okay, great. And then we can press the run mode. Okay, let me check, is there any error in here? Okay, so we can go to the troubleshooting screen to see that our EtherCAT connection seems like no error in here. I think the connection is okay. Then we can check the program. Yes, and some values. I think some values inputting here. I think we can now turn the camera to see actually what is the programming is running now. Okay, let's turn our camera. Okay, now we turning on the camera, and here is our Smart Studio. And let's see now this is the IO-Link value. So I try to move the IO-Link device. Just a second. Okay, you see the value is changed, so it means the IO-Link module is working fine. Then secondly, we'll try to move this. Try to operate this switch and lamp. Just a second. Okay. Okay, this switch also working very well. Okay, finally we will operate the e-stop, and this lamp is connecting to the safety features. So just a second. I think it's better to monitor the safety program to see what happened. Okay, here is our safety program. I just put it a little bit more big. Okay, and then drop here. First one, we will push the e-stop. Okay, now we'll release it. Finally, we will press the reset button. Okay, great. It seems like all functions work, and I think my video is ending here. I thank you that you listen my video to the end. I think you spent 1 hour or something. So I hope you like my videos, and please like, share, and subscribe to my channel if you like my channel. And I hope I can see you in the next tutorial. Okay, have a good day. Bye bye.